And I think that maybe the best way into your work on this novel physics of organisms that you've been pioneering is to hear about your particular critique of the Darwinian, Mendelevian, the standard model, you might say, as it still exists today, of human heredity. And this has great relevance, of course, because I think most people have the idea that there is a genetic basis for all disease, that science will eventually discover the genetic modifications of those diseases, that through genetic engineering we will perfect human beings and nature and so on and so forth, whatever that might mean. But you've thrown a real spanner into that argument, and it's based entirely on science. So what is the scientific history? What is the setup here for us? And,
well,
and what have you said? What are you saying?
It's very interesting because Neo-Darwinism and genetic determinism is what you've been talking about, that we're all hardwired in our genes. You know, that's really what has been taught to generations of school children and university students. They're still learning it, you know. That's really a travesty of what is actually the case, because very early on people know that environmental influences are very important. And so there was this argument between Lamarck and Darwin, so to speak. But as a matter of fact, Darwin was himself a Lamarckist, you know. Oh yeah, and but the Neo-Darwinists just disowned that part of him, and that's why they call themselves Neo-Darwinism. And what's wrong with Neo-Darwinism at heart is that they try to explain everything by genes, but they forget about the biology, the actual physiology, the chemistry, the physics, the mathematics. And so it's a really mind-numbing way of looking at the world, because you can explain everything in terms of selective advantage. However, it's not like that. And in fact, if you look at genetic engineering itself, in my book I went into that. Genetic engineering is a very powerful technique for looking at genetics itself. And when they did that, they found at the molecular level, it is totally Lamarckian, basically.
What is
Lamarckian is so-called inheritance of acquired characteristics, which means that the environment has quite a strong influence on your heredity, to the extent that it can even modify your genes. And that's what molecular genetics has been telling us for a long, long time. And even before the human genome was being sequenced, yeah, people knew that. And they already talked about the fluid genome. By the way, I have another book called Living with a Fluid Genome. There are several other books that you haven't mentioned. And that book enlarged on what I talked about in the genetic engineering book about the fluid genome, about how environmental influence can mark and change your genes, and how this can be passed on from one generation to the next. And so, obviously, you know, the kind of usual tale about if the giraffe, how did it get such a long neck? By stretching its neck. Well, we don't know if that's how it got its neck. But at the molecular level, those mechanisms are very clear-cut. They are very Lamarckian. And so what we have to do is to look at genetics in a very dynamic and circular way. This kind of circular causation, that's, you know, circular causation is how nature behaves, how nature is. Nature has a kind of a circular economy. So this also spreads into the physics. It's a kind of a circular thermodynamics.